All right, it is 11:40. I think that's when we are officially supposed to start, so let's get rolling. I'm going to talk about Elasticsearch suggesters, so if that's not what you were expecting, you're in the wrong place. My name is Brett Hazen. I'm a principal consultant at a company called ILM Professional Services. It's a local consulting company here in the Twin Cities. We're hiring, it seems like everyone is, so if anyone's looking for a great job in the Twin Cities, come talk to me later. I am primarily a C# and C#.NET and JavaScript developer, although I've done quite a bit of other things based on what clients need. Over the past year, I've also done Python, a ton of DevOps, both with Jenkins, with Azure DevOps, obviously some stuff with Elasticsearch and some other data stores. I'm a runner, very amateur musician, singing a couple choirs, and a bird owner. If you didn't realize, that's not a picture of me, that's a picture of a couple of my birds. All right, so why this talk? So I was at work one day, programming like this, as we all do, was working on a project where we had metadata about data. So it was basically a tool that allowed business to figure out what data they had, and there was some health checks on it so they could look at things like the quality of the data. And we had an API that was performing poorly, and we needed some more robust search capabilities, so we started using Elasticsearch. And then after that, and business saw that there was value to having a good tool like that, they wanted more things, because when you give business something good, they want more good things, which is good. It keeps us employed, and we get to solve interesting problems. And so we needed to implement Autocomplete, and since we're using Elasticsearch, there's several ways to do it, but there's one out-of-box ways, which is using a suggester. So I thought that was pretty interesting. There's some other suggesters. I wanted to look into them more, and I thought maybe other people would find that interesting too. Looks like some of you do, so that's why we're here. So the general plan is to cover some Elasticsearch basics, because some of the stuff I'm going to talk about will not make a ton of sense unless you have an understanding of some of the basic parts of Elasticsearch. So we'll go over indexing and mapping and analyzers, because those are really at the core of how Elasticsearch works. We'll take a tour through each type of suggester with an example, and then Q&A at the end. If you have questions as I'm going through, feel free to put your hand up and I'll answer them as I go too. You don't need to wait to the end. If it's something I just haven't gotten to yet, I may just ask you to wait until after that. But who in here has used Elasticsearch? Okay, so actually quite a few of you. Who has used Elasticsearch suggesters? Okay, it's not many of you. So for those of you who haven't used Elasticsearch, if anyone's not super familiar with what it is, it's a distributed RESTful search and analytic engine. And there's some other stuff up there. That's what Elasticsearch says it is. The company that makes it is called Elastic. If you've heard of the ELK stack, it is the E in ELK stack. It's really good at indexing data to make it fast to search. It is not a database. I see people confuse it with document databases. It feels like it at times because you're indexing JSON documents like you would with Mongo or something, but it doesn't have transactions like we have in the traditional relational database world, and it doesn't have some other features, but it is very, very good at searching things. So to cover some of those Elasticsearch concepts, Elasticsearch has indices. So you store all your data in an index, and in a particular instance of Elasticsearch can have more than one index. And each index has analyzers, and analyzers are made up of character filters, tokenizers, and token filters. An analyzer will have 0 or more character filters, 1 and only 1 tokenizer, and 0 or more token filters. And these can either be built-in or custom. Elasticsearch ships with a lot of them out of the box. Some of them you actually need to configure to use. We'll look at a little bit of that. You can also define these globally for your Elasticsearch cluster instead of just at the index level. The other really important thing is mappings, and that defines the shape of data store in Elasticsearch. So if you think of like a database schema, it's similar to that. There used to be a concept of types in Elasticsearch in the early days where within an index you would also have type. That led to a lot of really bad analogies, including from Elastic and some of their documentation, where people compared types to tables in SQL, which is just not a great comparison, and people tried to use Elasticsearch like SQL. And bad things happen. So types are no longer there. They were deprecated for quite a few versions, but as of Elasticsearch 7, which is the most recent one, they were finally removed. So the way you put your mappings in has some pretty big implications on how search works, and we'll look at a bit of that too. So what do analyzers do? And I think it's going to be the most instructive to look at this with a specific example. So if we look at the text domain-driven design by example, and we look at it using the standard analyzer, which is what is used if you store data as a text. It has no character filters. It uses the standard tokenizer, and the token filters it uses are the standard, lowercase, and stop. And I should have updated these slides because this changed as of Elasticsearch 7. The standard token filter got removed. It had been in there forever as a placeholder in case they ever needed it, and it never did anything, so finally they decided they could just get rid of it. And there is an API for helping debug these analyzers we'll take a look at as well. So if we look at what our text domain-driven design by example looks like, after the tokenizer, the standard tokenizer splits things on white space, so we'd have these tokens for each word. And after it passed through the standard filter, which again was removed in Elasticsearch 7, nothing would happen because it didn't do anything. After the lowercase filter, it just lowercases everything, pretty self-explanatory. And after the stop filter, which is actually disabled by default, it would not look any different. Now what the stop filter does is remove stop words. If you are not familiar with what those are, it's basically just parts of speech that are super common and not particularly useful. So in the English language, it's words like by, the, of, so prepositions, those parts of speech. So if the stop filter was not disabled, it would have removed the token by. And so what would actually be indexed in Elasticsearch from the text domain-driven design by example is these tokens that are left, domain-driven design and example. So that's kind of high-level whirlwind tour of how analyzers work and how your data is going to get indexed. Questions on that? Okay. So we'll get into what suggesters are. So what is a suggester? Suggests similar looking terms. Nothing too earth-shattering, but they're pretty useful. And what that means depends on what type of suggester you're using. Their documentation says that parts of the suggest features are still under development, but it doesn't say which parts. It said that for quite a while. So I guess they're still working on something, maybe, but they won't say what. I can tell you, when I originally wrote this talk, I was using Elasticsearch something like 6.4, and now we're on 7.04. I've looked through the change logs for every version they've released since then. The only things that have changed with suggesters are bug fixes. So they're a stable feature. They've been around for quite a while. There are three types of them. There's a completion suggester, a term suggester, and a phrase suggester. We're going to start with the completion suggester. So before we move beyond autocomplete, we're going to start with it. It provides autocomplete, but it only works based on a prefix, so that could or could not be useful depending on what type of autocomplete you need to implement. And it's stored as a special data structure that makes it very fast. That data structure is called a finite state transducer. I looked at the Wikipedia article on that to see if I could give a better explanation, and all the math symbols quickly reminded me why I didn't take more math in college. But they are costly to build. What I mean by that is it takes more time when you're indexing your documents to create these because they're stored in memory, which is also part of what makes them super fast. And you want to be a bit weary of them being stored in memory because Elasticsearch is built on Java, so it's running in the JVM. So you may run up against memory pressure if you haven't allocated enough memory to your JVM runtime, so just something to keep in mind. So we're going to look at that in a demo, but just before I start a couple notes on demos, I'm essentially starting with an empty Elasticsearch instance. It's local, running on my machine. There might be some data in there. None of it is data we're going to use. I'm using the newest version of Elasticsearch 7, which is 7.0.4, I believe. So no data is pre-populated. I am going to do all of the demos using the REST APIs. If I were doing an actual production application, I would not be using the REST APIs. There are client libraries for pretty much every language that I can think of. I have personally only used the ones for .NET. They are very good. They make it easy to work with Elasticsearch. But when I've had issues with a query not returning the results I want, it's usually been because I've written the query poorly. It's a lot easier to debug it using the REST API than through the clients. So for each demo, we're going to create a new index that is customized for our needs. We're going to put some data in and see how the type of suggester we discussed works. So I am going to use a tool called Insomnia. If you are not familiar with it, it's very similar to Postman. It's just a basic REST client, and I am pretty positive that that text is too small for you guys in the back. So let me know when it looks big enough. Everyone can read that now? Cool. So we're using the REST API. The way this works, I've got this running on my local host. 9200 is just the default port, and the /test is just the name that we're going to use for this index. So you use a put request to create an index, which is a bit weird to me, but we're not here to argue the semantics of REST APIs. So what I'm going to do is create mappings, and mappings have properties. If you've looked at Elasticsearch before, there would be one more level to this nesting, which would have been that type that I mentioned was removed. So if you are looking at examples and you see that difference, that's why. And I'm going to use one property, and we're going to call it name. We're going to give it a type of keyword, and then we need one more. I'm going to call it suggest. So name and suggest here are arbitrary. They're just names that I'm giving to these properties. And then the type is specifying which type of field that we want Elasticsearch to use, and that controls how this is going to be indexed. So for suggest, we need to use a specific type of completion. All right, so we have an index. We'll put some data into it. Pretty similar URL. We're just going to add /_doc to the end. And if I wanted to, I could also specify the URL at the end of this, but we don't need it, so I'm just not going to bother. So we're going to put some data in here, and since it was finally nice in Minnesota this past weekend, although you may not believe it, by today I was doing some gardening stuff, so we'll use some gardening products. So for the name, I'm just giving it text, and then for suggest, the syntax for that, you can kind of put in whatever you want in an array. So I'm just going to use both words. In practice, if I was indexing something, I would probably just be splitting on white space to put those in there. So I'm going to do that. We'll add a spading fork too. And how about a fountain? Okay, so we've got a little bit of data in there. To actually use the suggesters, you use the search endpoint. That's different from some earlier versions of Elasticsearch. And the versions, I think it was only like 1 and 2. It's been different for quite a while. There's a different endpoint for suggesters. They're part of search now, so you can do both search and get suggesters at the same time, which is pretty useful. If I were to just send an empty request, this is going to search, do everything, return me some JSON with hits. That's the equivalent to doing an actual query. So if we were trying to do a query for everything, we'd use a match all query. It's going to return the same thing, but we're not here to talk about queries. So the way you use suggesters is you apply this suggester key. And then for each type of suggester you want to use, you have to specify a name. So I'm going to call this autocomplete. This is arbitrary. And then, because we're using the completion suggester, we need to specify a prefix. I'm going to use FO because I know there's data that's going to come back. And then you specify which type of complete suggester. So we're using the completion suggester. And then you tell it which field to use. So we called it suggest. And of course, I typed something wrong, so I am just going to go grab part of this quick. So we get nothing back in hits, which is good because we're not searching on anything. In some of the older versions of Elasticsearch, that would get returned by default, and you'd need to specify that you want 0 results. But what we're interested in is down here in the suggest. In the completer, which is what we called it, we're getting back results. So you can see we got back fork, and fountain, because that is the data that we specified in here. So we can show those to our users. They get a bit of autocomplete. One thing that is maybe not great is that we're getting back duplicates. If you want to not get those, you can specify another piece of this request to say skip duplicates. And then we'll only get fork back once. That option has been in and out of Elasticsearch. It was in there in the early days. It was removed for a while, then it got added back in one of the later versions of 6. One other thing you may have noticed if you're paying really close attention to these results is this underscore source field. This is returning the entire document, which in our case probably isn't a huge deal, but if you have a big data set, that could be a lot of data for what you're sending over the wire. So if you want to disable that, you can do this source false, and it streamlines your results a bit more, just being conscious of what we're sending over the wire. So one last thing I have found useful with the completion suggester is if your users are like me, sometimes they are challenged with typing. So if someone typed in fur, we'd get nothing, but we have something similar in there, so you can make the queries fuzzy. And what this lets you do is give some leeway to typos. So you can set this to integers. In practice, I've usually set it to auto, and it's worked out pretty well. If I do that, again, I've typed something wrong. You can see then we do get a result back. So just something you can do to make life a bit better for your users, because sometimes the worst thing you can do is show no results. Maybe if you weren't getting any results back, you'd just want to show a message indicating that, but showing absolutely nothing, probably going to make most users think something's broken. So that is really it for the completion suggester. Any questions on that? The next suggester we're going to look at is the term suggester. So this is most useful for correcting a user's spelling. And the suggestions that it provides are based on edit distance, which is a term I wasn't familiar with. So what is that? It's basically how many characters need to be changed for a term to match. So if two things don't match, how far apart are they? So for an example, let's say the user provided the text domain, but they screwed up a couple of characters there. The corrected term domain has an edit distance of 1 because we only had to move one character or change one character to make it correct. All right, so let's look at a demo. So I'm going to delete the index that we were using before because we don't need it. We will set up a new one. You do not need to use a specific type of field for the term suggester like you do for the completion suggester. So we're just going to do a title of type keyword. We're going to use books for our data this time. So I'll create that. We'll create a couple of documents so we have some data with which to test. And our request to use the suggester is going to look pretty similar to what we had before. call it spell check. Instead of prefix this time, we're going to specify text. Going to use the same typo we did in our example. And then we're using the term suggester, so we'll do that and then specify the parameters to it. Our field is called title. So if we do that, we get back no results, which is actually what I expected. But does anyone have any idea why that is? No? Okay, usually when this happens, my first thought is, I've done something wrong with the query, but I know that I've set this one up right. So then my next thought is usually, the way the data is indexed is not what I'm expecting. And the most useful tool I found for debugging that is there is this analyze endpoint. So again, it's the root URL of where our Elasticsearch instance is living, the index, and then /_analyze. And what this allows you to do is throw text at your index and see how it's being indexed. So the text we are going to look at is domain-driven design because we expected that to show up. And then you can tell it which field you want to use. So we called it title. So if we do that, this is how it got set up. So the text is only in there as the exact string we gave it. And it's that way because we used the keyword field type, which basically just takes something as it is and puts it in there exactly like that. You can also use this endpoint to check specific analyzers. So if we do the keyword analyzer, and I spell analyzer right, we'll get the exact same thing back. So the actual analyzer we probably want to use is the standard. That looks more like what we wanted because we want each word. So I'm going to delete that index. And I'm going to change this type to text, which I know uses the standard analyzer. I didn't have to delete the index. There is a way you can update mappings. It's just a little bit quicker for the sake of a demo. So I will re-index these documents. And now if we do this search again, we actually get back the corrected option domain. A couple other things I'll point out here is there's this score. That's basically just how good of a match this is. So how close is it to the text that the user provided? And then there's this frequency. So the frequency is how many documents in your index in which that text appears. So it could be useful in figuring out what's probably the most relevant thing to a user. So the term suggester is probably actually the simplest one. That's the crux of what there is to it. There's some more options. If you really want to look into it, I haven't found any of the rest of them particularly useful. I will mention Elasticsearch's documentation is fantastic, so if you're interested more in what's available, go check that out. But otherwise, questions on the term suggester?
You got an extra E in the word check on spell dash check. How's that?
So the question was, I've got a typo here in spell check. So within this suggest object, this spell check here is just arbitrary. So I could actually do multiple suggesters at once if I wanted. And that's just my way of when I get them back, knowing which suggester is which. So it's just an arbitrary name that I assign to it. Any other questions at this point? So the next type of suggester is the phrase suggester. It's like the term suggester, only it's fancier. You'd use this for building a did you mean feature. So if you've ever typed a phrase into Google and typed one of the words incorrectly, and it's asked, did you actually mean this? This is what you'd use that for. It's based on an n-gram language model. So what that is a way of tokenizing a string. So for an example, if we're indexing the string domain and we use a gram size of 2, we're going to find every 2 consecutive letter combination from that. So if we used a gram size of 2 on that text, we'd get the tokens DO, OM, MA, AI, and IN. So that's useful for individual words. But then when we're looking at phrases, what I've seen them referred to is shingles instead of grams. So for an example, if we're looking at domain-driven design and we use a minimum shingle size of 2 and a maximum shingle size of 3, which is like gram size, except now instead of for letters, we're doing it for words, we'd get the combinations domain-driven, driven design, and domain-driven design. So that's how we want to think about how our text is being analyzed and indexed and stored for searching it. Questions on that? Okay. So I'm going to delete our index again. And the setup for this is quite a bit more involved. So we haven't seen this yet, but we're going to have this settings part of our index now, because we need to configure a specific analyzer so that we can store the text like that. So this is all boilerplate, just what you need to do for creating custom analyzers. So we're going to have a filter and an analyzer. You can specify multiple filters and multiple analyzers. I'm going to call this one shingle. That name I'm giving it is just the name that I'm assigning to it. There's no significance to it. It's just how we're going to refer to it later. And then the type of filter we're going to use is the shingle filter. And we have to give it a minimum gram size and a max gram size. And then we need a custom analyzer too. And I am going to call this trigram because we're using gram size of 3. The type of this is going to be custom. We don't need any character filters. We do need a tokenizer because remember, every Elasticsearch analyzer has exactly one tokenizer. I'm going to use the standard tokenizer, which is just going to split things on white space for us. And then we need filter. We need to at least use our shingle filter. So that's how you would set up a custom analyzer. So we have this custom analyzer called trigram that's using our custom filter called shingle, which is really using a built-in type of filter that's in Elasticsearch out of box. We just have to tell it how we want it to work. So then we'll have our mappings we should be used to seeing by now. We're going to stick with our book theme here. And this will be a slightly new syntax we haven't seen before. If you are indexing the same text multiple times, you can specify what are called fields, and those are basically just nested properties. So if I want to index title more than one way, this is typically what I've seen people do and what I do, because I may want to use title as searchable text, but I may also want to use it as a filter. And if you're trying to filter things, you're going to want an exact match, and then the property type of keyword is a lot more useful. So you have fields, and then it's just the same syntax as properties. So I'm going to call this trigram. You give it a type, we'll make text, and then this time we're going to specify an analyzer. Now we haven't specified an analyzer for anything we've set up so far because every type in Elasticsearch has a default analyzer. So we're going to tell it to use our trigram analyzer, and if I've actually typed everything correctly, no, but rather than trying to fix that, I'm just going to go grab something that I know works. Okay, so now we've got an index set up, so we should be able to use the phrase suggester. So we'll stick with the same books we used in our previous example. And this is going to look pretty similar as well by now. I think you're probably getting the point that the suggesters are pretty similar with how you use them. We're going to use text again for this one. We'll use the same typo as before. This time we're using the phrase suggester. And when you have those fields, the way that you refer to them is just by the top level field, then dot, whatever you named the other one. So since we named that field trigram, it's title.trigram. So if we try running this, we're getting nothing back, which is what I expect. Is that what anyone else expected? Any ideas on what's wrong with it? No. Okay, so again, usually if this sort of thing happens, I go to my trusty friend, the analyzer, and then ask it, all right, what if I send stuff to this field, what is it going to look like? So this is what we're getting. So things are being tokenized the way we expect. It may be surprising to some people to see that we have gram sizes of less than 2. That's because I didn't specify an option to take out those when we set up the filter. We certainly could have. But the other thing is, everything's still uppercased, which probably isn't what we want. So we just need to make a minor change to our analyzer and add the lowercase filter. So we can go back before we start indexing data and make sure that that's doing what we want and that looks more correct. So I know that was kind of the same thing we went through before, but I just wanted to show that that analyze endpoint works for custom analyzers as well as out-of-box analyzers. You can post configurations to it as well, so if you're just trying to figure out how to get an analyzer to work before you use it, also a useful tool there as well. So we'll put some data back. And then if we go try to use this suggester again, we actually get something back, which is what we expected, and it's got a score. One of the other parameters I found useful for this is there's one called confidence. By default, this is at 1, and you can set this to various values, and what it does is basically controls how forgiving the algorithm is. So by default, it's only going to return things that score higher than what was the text the user provided. So if I set this really low to 0, it's going to provide more things. And you can see it actually gave us back the typo we put in, which may or may not be useful. Typically, when I've been working on Elasticsearch implementations, I don't want to show something like that to the user if it's not actually going to match any search that they could do against our Elasticsearch instance. And the phrase suggester has a pretty neat feature that will let you actually check against your index. Excuse me. It's called collate. And what it lets you do is actually specify a query. So I'm going to use what's called a match phrase query. And this is just going to check to make sure that the phrases are an exact match. So I'm going to put title here because that's the field against which we want to match. And then I'm going to put suggestion with this syntax, which basically just means that every suggestion that it finds is going to be run against this query. So if I do that, we get 0 results back. I probably just screwed up something with the query, not a big deal. If you want to get back results regardless of if they matched or not, you can specify this prune option. And if you specify it in the right spot, you'll get back matches regardless, and it'll tell you if it's a collate match, true or false. So it's saying false there because that didn't match anything. So if you think of why that's useful, If I have users who are searching for specific things and it's not matching anything in our website or whatever they're searching, I probably want to know about that because it either means that our search is not working correctly and users aren't able to find what they want, or maybe they're looking for things that we don't have. So if you think, like, if this is an e-commerce site and users are searching for something consistently and it's not matching anything, maybe there's something we need to add. So just something to think about. One last thing with the phrase suggester that's particularly useful is you can also highlight things. And what that lets you do is wrap what the corrected text in a pre-tag and a post tag. So it makes it super easy to be able to style things when you're displaying it to a user. So you can see now when it returns the text, it also returns a highlighted version. So I could use that M tag to, like italicize or something to give the user a visual indication of that's what we changed from what you put in. So that is it for what I have for the phrase suggester. Any questions on that?
Where is this n-gram came in place? Like you define 2, min, and the max, right?
Mm-hmm.
So I just want to know that how that has played here, because when you showed me the analyzer, right, it was all indexed like separate word because of standard tokenizer.
Mm-hmm.
I'm just trying to figure it out, like when you are tokenizing the words, where is the n-gram min and max playing the role?
Yeah. So the question was just asking for a bit more of clarification on how the n-gram filter that I set up came into play. Because this looks like it was just used with the standard analyzer. So if I had just used the standard analyzer, I would have only gotten domain driven in design. By using the n-gram filter, we also got the token domain driven and domain driven design. So if we hadn't done that, we wouldn't have actually been able to match against a phrase because we wouldn't have had a token of those phrases. Does that answer your question? Okay. Any other questions? Okay. So I said there were only 3 types of suggesters. That's kind of true, but not completely. There's also what is called a context suggester. It's used with the completion suggester, but it allows you to specify context too. So you can do autocomplete, but then you can also do some additional filtering, and there are 2 types of context currently. There's a category filter, which is exactly what it sounds like, and then there's a geo filter, which is also what it sounds like. The geo filter lets you do filtering based on latitude and longitude coordinates, so if you think in the context of if you have a search where you're searching for locations, you could allow, use the user's location to restrict what results they got to make sure they're the most relevant to them. So it requires a spatial mapping, though, to do the geo one, so something to keep in mind. It increases the index size of the completion field, so if you're concerned about the size of your index, you want to be wary of this. And it's stored entirely on the heap, because again, this is running in the JVM, so tread lightly with this, with how much extra data you're adding and how much memory you're using. So as far as setting those up, it looks pretty similar to our first example. We're going to stick with our theme of books. But this time we're going to add a genre. We'll make this a keyword because we're probably only going to ever use that to filter or display. And then we're going to have our suggest again. We still have to use the type of completion, but then we're also going to specify contexts. So when you do that, contexts will have a couple pieces of information. You're always going to have to specify the type. This is if it's a category or a geo. We're going to use category. You're always going to specify a name. We're going to call this genre. And then this is an optional thing. but you could also specify a path. And I'm going to do that because we're already indexing the data that we want to use for our category. So if I do path, I can just say use a genre. And if it was like a field, it would be, like title.genre or whatever. Okay. So we'll keep using our same text. We're gonna have to give it a genre this time. This sounds like a development book. And because we used that path to tell it to use another field for the context, we don't have to do anything different with how we specify this field. If we weren't, there'd be some extra syntax to it. We'll add another book in a different genre. It sounds like a biography to me. So when we go to actually use that, it's going to look pretty much the same as when we were using the completion suggester before. We're going to give it a prefix. I'm going to tell it we're using the completion suggester, tell it which field to use. But if we do that, it is unhappy. If you are using contexts with a completion suggester, you absolutely have to specify the contexts. So if you want to be able to do it both ways, you're going to need 2 different fields, but that's going to take up a lot of memory, so just something to think about. The way you specify those is contexts, and this is just an object. We called ours genre, and then you specify which values you want to allow. So we had genres of development and biography. So you can see we're getting back 2 results because we allowed all of the genres we have in there. If I take one of these out and don't change anything else on the request, then we only get 1 back because we're only allowing the genre of development. So if you think of this from a practical standpoint, if you're implementing a search that's a faceted search, so we have books, if we're building like a bookstore, typically you're gonna have a faceted search where users can select which genres they want, so you could use something like this to help make sure that your autocomplete is only showing them relevant results. One other thing I'm gonna show with this, and this is not necessarily unique to the context suggester, you can do this with just the normal completion suggester, is we have a bit more control over that score that comes back. So in addition to just the input, I can specify a weight too. So I'm going to specify a weight of 2. So again, it's that suggest field with an array, but this time it's an array of objects to give it a bit more information. I'm not going to give a score to our other book. So if we run this again and include both our genres, you can see that when it comes back, the score here is 2. And it looks like I had a typo somewhere. And the score for the value that came from development was only 1. So in this use case, since they're the same text, not a huge deal, but if you think of maybe you want to push values from a certain genre up more because you're trying to get rid of books, if you're like making a bookstore, just one way you control it. If you don't want to have to re-index your entire documents every time you do that, you can also specify it at query time. I'm blanking on the syntax of it though, so if you're interested in it, it's called boosting. So you could look at the documentation and basically you can influence that score without having to re-index your documents, so just another way you could do that. Okay, so we're actually doing pretty well on time. Questions about the context suggester. Okay, so I think we have lunch after this, so if people want to just be done early, that's fine. Otherwise, I have one related demo I can show you if people are interested in that. I'm getting some, okay. We'll look at that related demo. So I'm not going to type this all out. This is an example that I took from a project I was working on. When we talked about the completion suggester, I mentioned that it only works on prefix. That is not always particularly useful because it requires users to type the right thing to get relevant results. And if you're indexing things that maybe start with a word like the, they're not going to do that, and then they're not going to get relevant results. Not great for users. So this is a beast of an index setup. So again, we've got some custom analyzers set up, and there are quite a few in here. So this keyword analyzer is not super relevant to what we're doing. Just another example. We're going to use this edge n-gram analyzer, which is similar to the one we were using before. So it's a tokenizer that's defined down here. It's an edge n-gram, which is a little bit different than the n-gram one. This is useful when you want to create like more combinations of words. So when you don't want to just have like these tokens, it's a bit more flexible. And you tell it which token characters to split on. So it's splitting on letters. So when we say pass in letter here, it's saying split on anything that's not a letter. So the way it indexes the data is not quite the same. And I feel like that doesn't make sense based on a description, so we can look at what that data actually looks like. But that tokenizer is defined down here, and then there's an analyzer up here, which is using that tokenizer. One other thing I think is neat about this demo to point out, so our mappings look pretty similar. We've got a name that's a type text, then we've got fields. So we've got multiple fields, keyword string, not super relevant to us, edge n-gram, which is using text and that custom analyzer, but it also has this search analyzer. So when Elasticsearch indexes your documents, it analyzes it, but when you're searching against a particular field, it also analyzes the text that was passed in. Now, if a user is passing text in, you probably don't want it to be run against an edge n-gram analyzer because you're not going to get good results. So you can specify a search analyzer that says, hey, I want the text to actually look like this before it searches. So this edge n-gram search analyzer is just lowercasing what they put in to make the search case insensitive. So we'll create that. We're going to add a couple things with names. And this query is going to look quite a bit different because it's not a suggester. So we're going to do a query that's of type prefix, and we're going to use that field. So you can see I started typing in the word driven, and with the completion suggester, we wouldn't have received anything because it's not at the beginning. But because we used that special type of analyzer, we actually got things where the word was at the end and in the middle. So looking at what that text actually got indexed like, looks pretty similar to what we've seen before. But again, because we use that different type of query, we were able to get different results. So kind of a whirlwind tour through that, but just one other way you can implement a type of autocomplete. Questions on that? All right, so any questions on anything at all we went over? Okay, so either you all are really comfortable with Elasticsearch suggesters now, or you have no idea what I was just talking about. So we'll hope it's the former, but really, any questions? Okay. If not, I will say I am supposed to remind you to do speaker evaluations on your way out. Otherwise, thank you for your time. If you want to get a hold of me after the conference, if you think of questions, my Twitter handle's up there at Brett E. Hazen. That's probably the best way to get a hold of me. I'm not super active posting things on Twitter, but I'm on there a lot. Otherwise, I will be around the rest of the conference, so feel free to come ask me questions at any point about Elasticsearch or any other development topic. Otherwise, thanks for your time, and I hope you all have an enjoyable rest of your conference.